Okay, so we're looking at areas between curves. I know a few of you already started this, but we'll have a video anyway. So for instance, if I have two curves, one fx, one gx, and between x equals a and x equals b, there's going to be a shaded area. Okay? So this area shaded is going to be defined as the integral from a to b along the x-axis of the top function minus the bottom function. Now in this particular case, fx is above gx for the entire range, entire domain, a to b. Okay, copy that down. So when we have a second case where the functions cross over and then in one section one function's on top and then changes over, then you just have to break it up into two areas. And the hard part is just making sure that you find the point of intersection and seeing if that point of intersection lies between A and B, because sometimes it doesn't, but often it's not, it does lie in between. And you just have to use algebraic methods to find that point by making the two functions. So C is found when fx is equal to gx, and you solve the equation. It turns into a quadratic or a cubic, and you just have to use your techniques, use your graphics calculator. But in the first case, the first area, the brown line is on top of the purple, so gx sits on top of fx, so it's gx minus fx from A to the point of intersection C. Even though we're trying to find from A to B, we have to break it up into two areas. And then the second area is from C, which you have to find. Then goes fx sits on top of gx, so you change the order, and then you just add the two areas together. If by chance you have subtracted them in the wrong order, you'll end up with a negative answer, so you'll know that you've either got your sketch wrong or something's gone wrong. Okay, copy that down. Okay, so looking at a couple of examples. In the first one, excuse me, it's two straight lines. There's no point of intersection involved. We're just trying to find, this was given as a sketch, going from 0 to 2. 2x plus 1 sits on top of it, sits on top of x, so it's just a straight subtraction from 0 to 2. So there's the first function minus the second function, and then 2x minus x is 1x, and the plus 1 just stays the same. Then we add 1 to the power, divide by the power, add an x to the 1, and then put in the numbers 2 and 0. 0 is a nice number, just subtracting 0, end up with 4, and we have units because we're finding an area. Okay, copy that down. And next one, okay, find the area bounded by y equals x, which is a straight line, and the parabola y equals x squared minus 2. So your graphics or Desmos will show you what the sketch looks like. Okay, back on, had a bit of a cough. Okay, so at the point of intersection, what we're trying to find is we need to find these, where these two curves meet, so that's where it's going to be bounded. So the parabola equals the straight line. We can't solve the equation, so we've got to bring x across, make it a quadratic, factorize the quadratic, solve the quadratic, so end up with 2 and minus 1. So that value is 2, that value is minus 1. And then the straight line sits on top, so we just do the straight line minus the parabola, and just be careful with your minus signs because we've got minus and a minus make a plus. Okay, then we don't have to change the order. In here I've just left it as it is. Okay, so we've done x squared on 2 minus x cubed on 3 plus 2x, 2 to minus 1, chuck in the numbers, be very careful here, squaring a minus and cubing a minus, and then you've got another minus, so just be careful with those things when you do it. When I did it, I got 3 1/3 for the first bracket, 1 6 for the second bracket, so the answer is going to be 4 1/2. Okay, so we didn't practice any ones where you've got to change over, but you'll find some of those in the exercises here, 9H page 448. Have a go at those. Thank you.